Good morning, guys. Welcome to today's lesson, March 31st, right triangle proofs. March is almost over, thank goodness. Let's take a look at today's do now. In triangle RST shown below, altitude SU is drawn to RT at U. We have an altitude. If SU equals H, UT equals 12, RT is equal to 42, so our entire length here is 42. Which value of H will make triangle RST a right triangle with angle RST as a right angle? Okay, so if we fill in all of our given information, here's how our setup should look. What type of problem is this? Hills or SAS, you are correct. And more specifically, SAS, because we're looking for the altitude H, which is represented the side length of SU right now. Let's label accordingly. We have our segments, segment 1 and segment 2, our altitude, legs, and a hypotenuse. Remember, when we're looking for the altitude, typically we're using our SAS proportion of segment 1 over the altitude is equal to the altitude over segment 2. You may be a little bit unsure about what is segment 1 right now. Some students will use 42. Be careful, that's the hypotenuse. Our segment 1 is 42 minus that 12 for us to get 30 there. So it's going to be 30 over the unknown altitude, which they put as H, is equal to H, the altitude again, over segment 2 of 12. We'll cross multiply. We get H squared is equal to 360. Now, you may not know how to simplify the radical. You can put that into your calculator and see the decimal value, and then put your answer choices in as well, see which decimals match. But the biggest perfect square that divides evenly into 360 is 36. 36 times what will give me 360? 10. One will simplify here. Of course, the perfect square of 36 would be 6 radical 10. Choice 2. Remember, it would have been hills if we were looking for one of the legs, most likely. Typically, when we're trying to find the altitude and we're given the segments, we're going to be using SAS. Our aim today, how do we prove triangles are right on the coordinate grid? You're going to notice that the lesson is very, very similar to yesterday. Anytime we're doing coordinate geometry proofs, we want to find all the slopes and we want to find all the side lengths. Now, more specifically for today, with a right triangle, right, think about what a right triangle has. It's a right angle, okay? And what type of lines are going to make a right angle? Perpendicular lines, right? Perpendicular lines form right angles. Now, on the coordinate grid, how do we show perpendicular lines? Okay, that's a lot of times, guys, on these coordinate geometry questions, really all of Module 4, a lot of this has to do with slope. Okay, slope is key. Slope, all right, and more specifically, what type of slope? It's those opposite reciprocal slopes. All right, so what we're going to do today, we're going to show the opposite reciprocal slopes, meaning the lines are perpendicular, meaning we have a right angle, and therefore it's a right triangle. All right, so the focus today, we're definitely going to plot the triangle. We're going to find all the slopes. Okay, to find all the distances, the lengths, technically we don't need that. I'm going to have you do that on your own. All right, you're going to see in a Regents question, a 4-pointer, you also need the distances. Today we're kind of just breaking it up. All right, right triangle, and then we're going to write an explanation. So step 3, you're not going to see in the video. You still should do that because in every Regents question, you're going to need step 3 as well. But for the video purposes, you're going to see steps 1, 2, and 4 there. Please find the distances on your own. Okay. So, example 1. Given triangle ABC with vertices A 2, 1, B 4, 5, and C 6, negative 1. Prove triangle ABC is a right triangle. Step 1, plot the triangle. I already did that. Now let's find the slopes. Slope of AB is equal to, we'll count from A to B. We have to go up 1, 2, 3, 4, right 2, so 4 over 2, which is the same as 2 over 1. And remember that slope is positive. Any line that looks like that is positive. Our slope of AC is equal to, we'd have to go from A to C. Usually we go from the point that's on the left and go to the point that's on the right. But anyway, it's starting down 2, right 4. So down 2, right 4. Now, are these opposite reciprocals? The answer is yes. If we simplify negative 2/4, that's negative 1 over 2. Always a good idea to simplify the fractions for the slopes so you can really see which ones are the opposite reciprocals. And our slope of BC, for good measure here, would be down 1, 2, 3, 4, 5, 6, right 2. And that was simplified to negative 3. But our focus here is this slope, our slope for AB, and our slope for AC. Very important. You can see that those are the opposite reciprocal slopes. Now, once again, find all the side lengths. You're going to find all the distances on your own. You can look back at your notes from yesterday. This problem is just the same, okay, as the worksheet from yesterday. So you can look at those distances. And the big part here is the explanation. How do we actually explain now that this is a right triangle? Okay. Now, this is an explanation you can use 100% of the time if you're proving that there's a right angle somewhere, and in this case that there's a right triangle. So here's what we're going to say. Triangle ABC is a right triangle because the two side lengths, the slopes of the two side lengths that we just found, which is AB and AC, okay, because AB and AC have opposite reciprocal slopes. All right, we're not done yet. Meaning what? All right, those have opposite reciprocal slopes, meaning they are perpendicular. Opposite reciprocal slopes means there's perpendicular lines. And the fact that they're perpendicular means what? Perpendicular lines form a right angle. This is absolutely an explanation you should memorize. All right, triangle ABC is a right triangle because the two side lengths we worked with, AB and AC, those have the opposite reciprocal slopes, meaning they are perpendicular and form a right angle. So a little bit work is necessary for this type of problem, but the explanation is much more challenging. Remember yesterday for an isosceles triangle, we found all the distances, and we said, hey, it's isosceles because we have two congruent sides. Pretty brief explanation. This is a little more in depth because we have to say, okay, we know there's opposite reciprocal slopes, meaning they're perpendicular, and what's that mean? We know that there's a right angle, and therefore it's a right triangle. So we're just showing, if we're proving it's a right triangle, we have to show there's a right angle on the grid. That is accomplished through slope. All right, we'll try one more together. Remember, go back and find all the side lengths as well. You're going to see as we go forward with this, the real regions questions, you're not just going to need the slopes. You're also going to need all the side lengths, so please make sure you do that. example 2. The coordinates of the vertices of triangle RST. Alright, you can see those as follows. Alright, we're proving it's a right triangle again. So it's good to think about at the beginning of the problem, where should the right angle be? Alright, would it be at R, would it be at S, or would it be at T? If we go back to the last one, right, we found AB and AC had the opposite reciprocal slopes, so the right angle was at A there. Where do we anticipate that the right angle is here, R, S, or T? It should be at T. Let's go show that. So RT and TS should have opposite reciprocal slopes. Let's show it. So our slope of RT equals 2. We're going to go up 1, 2, 3, 4, 5, 6, 7, 8, and write 1, 2, 3, 4, 5, 6. So it'll be 8 over 6. And our slope of TS is down 1, 2, 3, right 1, 2, 3, 4. So down 3, right 4. The question is, are these opposite reciprocal slopes? Yes, they are. We got to simplify that top one. 8 over 6 is really 4 over 3. Now remember what makes them opposite reciprocal slopes. Remember they're flipped and a different sign. So the fraction is just flipped and the signs are opposite reciprocals. One of them is positive and one of them is negative. For good measure, we're going to find our other slope for RS, which would be up 1, 2, 3, 4, 5, right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which is 1/2. But once again, guys, our focus is on RT and TS because those are the side lengths that form the right angle. They have the opposite reciprocal slopes, meaning they're perpendicular and form a right angle. Alright, so real quick, just kind of say this explanation in your head. Pause the video. Say the explanation in your head. You can even start to write it down and see if you have it. Okay, but it should look as follows. Triangle RST is a right triangle because, alright, what are the two sides? Because RT and TS have opposite reciprocal slopes. And what does that mean? Meaning they are perpendicular and form a right angle. Now please make sure you go back. In addition to doing examples 3 and 4, which are below, find all the side lengths as well. That's great practice. Okay, remember Pythagorean theorem. Make a right triangle. And if you have questions, as always, alright, contact me on Remind. I know this is a little bit new. Okay, this was the beginning of Module 4 where we found slopes and distances. Now we're just bringing it all together and writing an actual proof out of it. Alright, this explanation, once again, should be memorized. Very important. Opposite reciprocal slopes means they're perpendicular and form a right angle. If there's a right angle, of course, it's a right triangle. Alright, guys, I look forward to hearing you throughout the day. Have a wonderful rest of your day, and I'll see you mañana.